Alright, so in this video, we'll be looking at the super keyword, which is very essential for inheritance in Java. So the super keyword is essentially used to call the parent constructor from a child class, and also it's going to be used to execute the parent's original version of a particular method. Then in other cases, the super keyword is also used to refer to the original fields or variables that might exist inside of the parent class when you want to make use of them inside of the child class, as it were. But in the last instance, we really get to exercise that for this particular course. So we're just going to be looking at the two ways that are definitely going to be required or to be tested when you are making use of inherited classes, as it were. So let's actually go ahead and start by defining a class that we can work with. So inside of this file, super keyword Java, I'm going to create, I think maybe I'm going to create 3 classes. We'll see. So I'll create a class called rock. Then for the fields, or for the class methods, class variables rather, we're going to have the sample number, which is going to be the number of samples we have for that particular row. Then maybe we can have a private string, which is a description of the type of rock that we have. Then we also have a private double for the weight of the given rock. Then since okay, maybe we'll get to the getters and setters. Let's do the constructor real quick. So public rock. So when we instantiate an object of type rock, we'll definitely need the sample number. Then also maybe we can just take 2 parameters in this case. So we also need the weight, as it were. And then the description, because the idea is that we want to be extending this rock class to different, to specific types of rocks, like maybe say igneous, metamorphic, or sedimentary. So we actually just have to have a boilerplate for the rock, as it were. So we can set that one later on. So here we can then say this dot sample number is going to be equal to the sample number that is going to be provided when we instantiate that particular object. Then this dot weight is going to be equal to the weight that would have been supplied when that rock object was created. Then for the description, we can just set it to something like, so this we can actually set ourselves. So maybe we can say generic rock. So since these fields are private, if we were to extend these rock classes later on, we wouldn't actually have access to these because we've marked them as private. So there's actually one of 2 things that you can do. You could change entirely the access specification from private to protected, so that way the child classes can actually directly access this particular these fields, as it were. But that would actually break the whole concept of encapsulation in object-oriented programming. So the way we are going to go about it is the second way, which is to essentially just have getters and setters for each of these fields, as it were. So I can just come here and you can generate these. Basically, you can generate these automatically in your IDE, whether you're using IntelliJ or you're using NetBeans. Or even VS Code, like I'm doing in my case. You can see that I'm going to automatically generate these getters and setters. So you see that I now have my getters and setters automatically generated here. So let me just make sure that I have everything that I need for this particular. So you can see that with the set weight, get weight, set description, get description, set number sample, then rather sample number, then get sample. Set sample number, then get sample number. So this is done. Then maybe what we need also in this class is we need to have a void display function. So let's go ahead and do that. So we can call this display info. So this one is simply going to display the information that we have going on for our particular row. So I'm just going to say yes, system out.println out.println, then I can print here, I can print sample number, then I print the number of sample, the sample number rather, sorry. So sample number. So maybe I can just go ahead and copy and paste this maybe 2 more times. Here I want to print the description, so I will just change this variable right here to description. Then I need to remember to also modify this literal here. So I will call this description. Then here we can change this to weight. And we also need to remember to change the variable here from sample number to weight, as it were. Then here, since I want to do the shortcut, I actually have to import a system here. So let's go ahead and import static java.lang .system. Yeah, you might as well just import everything out and in, though I'm not going to be taking user input in this case, but I think it's fine if we do that, do it like that. So this is our row class, right? So you see that we have our standard fields right here, then we have the constructor from lines 10 to lines 14, then of course the getters and setters for each of these fields. Then of course we have an additional method called display info that is going to display information about our row object, as it were. So maybe let's just put, I want the weight to be, say, in grams. So you just say grams here. All right, so now what we need to do now is we need to demonstrate the concept of using super, is it? So we have this generic row class going on right here that I've just collapsed here. So you can see that this is the implementation of the row class. So we need to have, maybe let's have a class called igneous row that's going to extend the row class, as it were. So the class definition, class igneous row is going to extend the row class, as it were. Then inside of here we can add an additional field. So since it's going to inherit from the row class, right, we have that extends keyword going on. It simply means that it's going to take, or rather it's going to have access to these fields that we have going on here between line 6 and 8. So we can have that, and we can also add our own implementation, as it were, or rather our own additional fields. So here we want to have a boolean that is maybe going to tell us whether our igneous row is extrusive or intrusive. So we can say is extrusive. That's the additional field that we are going to have for the igneous row class. Then for the constructor, it's going to be igneous row. Then we say int and sample number. So here we just have to define the parameter list as we have to specify what we need to be provided when we instantiate our igneous row object, as it were. So we will need the weight. Then we also need the boolean, whether it's extrusive. So is extrusive, right? Then we have the body for the constructor now. So here now this is where we use the super keyword, is it? Because we want to inherit what we have going on from our parent class. So we just take these. So immediately you see that the sample number and the weight, they are going to be given by the row class, as it was, since it is the super class. So super is actually referring to the super class, as it were. So we'll come here, then say this dot is extrusive. We can set that to is extrusive, that would have been provided when we instantiate that particular igneous row object here, is it? Then for the description, we know that inside of the superclass, we have the description going on right there, is it? Right here inside of the row, the parent class row. So what we can do here in our case is we can simply use the set description function that is right there inside of the row class, right? So we can set description, and this one is going to be igneous row, as it were. All right, so here the reason why we're using set description is because remember that, let me just write here, there's a comment. So remember, fields in row are private, so you wouldn't actually just access them without making use of the getters. The getters and setters, they are the ones that are public, so they can be accessed by any other classes that inherit, but everything else is private, so it's going to have to be accessed through those, as it were. Then we can also have our own implementation of the display info method, as it were. So what we can do is we can have public void display info. Then for the body of the display info, we can actually have the first line. It's supposed to specify that it is referring to the what, the display info that is inside of the class. So we are going to call the parent method, which is going to give us these lines right here. So it's going to display the sample, the description, and the weight as well. But we can also go ahead and add our extra line, which is going to print whether the type is extrusive or intrusive, is it? So what we can do here is we can use the type, then we can concatenate with whether the rock is extrusive or intrusive, as it were. So what I'm going to do here is I'm actually going to use the ternary operator because I want to test for a condition before I display something, is it? So what I can do is I can say is extrusive. You might actually have seen this in the decision making where you have to about the ternary operator. So that's what I'm using right here. So is extrusive. If it is extrusive, then we'll output extrusive. Otherwise, we will output intrusive, as it were. Right, so that's how we can go about it. Then I think I can just go ahead and show you what's going on here. So I'll come in this main class right here. So you see, it's the main class because it is this public keyword going on before the class definition. But every other class that we have inside of this file is just a class. So it means these are just classes. They are not the main class. So it means our main method should reside inside of this main class here. So I'll just type main here, and my IDE will give me the main function signature. So what I can do is I can just go ahead and instantiate an igneous rock object. I will call it IG because it's kind of short for igneous. So new, I'm now calling the constructor there. So you see that the constructor expects for me to give it 3 parameters. So I'll say the sample number is 101. Maybe the weight is 250.5. Since the weight is a double, then is extrusive. We can set that to true. That's fine. And I can close out of this. Then what we can do is we can go ahead and out.println. Then I can just say, let me see, I want to use equal sign here, igneous rock, 1 2 3 4 5 like 4, yeah. Then I can just go ahead and take the IG object, then use the display info function right there. Okay, yeah. It's actually supposed to be display info like so. It's not supposed to be like that. Let me see if I'm still getting that. The one with an R. And right, so now it's everything sorted out. Yeah, so display info. So I can go ahead and just clear out the console, then invoke the Java compiler to run super keyword.java, and we should get that the sample number is 101, then the description is igneous rock, and the weight is 250.5 grams, and the type is extrusive. So that's how you can make use of the super keyword. So let me just zoom out a little bit so that I can show you. I can go through the code one more time. So here you see that on lines 5 to 45, we have the definition of the class called rock. So it's just a generic rock definition, right? We have the sample number, the description, and the weight. And for the constructor for the rock class, you see that it has this, it only takes 2 parameters, is it? Then, of course, we have the getters and setters. The only reason why we need the getters and setters is because we wanted to make these private fields accessible when this method is, or rather when this class is extended by child classes. But otherwise, we could just use protected here, and we would need the getters and setters, as it were. But then, if you make this protected, it simply means now that even a class that extends this row class can access these fields directly, and you wouldn't want that because that breaks the whole concept of encapsulation. So we actually need to have this so that we keep on enforcing the concept of encapsulation, which is one of the hallmarks of object-oriented programming, as it were. Then, of course, we also have this display info function going on here. So it's just going to display the sample number, the description, and the weight. Then for our class called igneous rock, you can see that it's extending the rock class right here. And it's also going to add an additional field called is extrusive. Then what we did on line 50 was to make sure that the igneous rock class had its own implementation of a constructor, but it's also going to be inheriting from the rock classes. So the way we tell the Java compiler that this class is going to inherit the constructor from the super class is to make use of the super keyword, is it? And we tell the Java compiler which 2 fields are being inherited from the super class. So here we are going to be inheriting the sample number and the weight, as it were. Then the additional field, we are implementing it right there on line 52. And then for the description, since the super class also has a description going on, right here, you see that the constructor right there, it has a description going on, is it? So in order for us to set a description, we're actually making use of the set description function right there, or the set description setter, as it were, which is essentially a mutator method. So instead of describing it as a generic rock, here we're actually now going to be specifying that this is what this is an igneous rock, as it were. Then for the display info function, again, we are doing the same thing. If you come back here, you see that we said it is the super keyword is used to execute the parent's original version of the method. So when we say super dot display info, we are actually running this implementation of display info right here. So we are going to get the sample number, the description, as well as the weight, as it were. But then we go on to add our own line on top of what we have going on inside of display info for the super class, as it were. So here we are now outputting whether it is extrusive or intrusive, is it, and we are just using the ternary operator. So you remember that the ternary operator says that for this condition, if this condition is true, then we are going to run this. Otherwise, we are going to run this. So here, when we ran our code, we actually got extrusive because we did set extrusive to true when we instantiated our igneous rock object right there on line 64 there. So yeah, that's how you can make use of the super keyword in Java. I didn't want this to be too long. I would have actually given you another example, but we are already going on to 20 minutes, as it were. So yeah, that's just about it for this episode. I'll see you in the next one.